Hello, welcome to Climate Conversations. I'm Claire Nazir. October 2023, Storm Barbet barrels into the UK, unleashing a deluge unlike anything seen in over a century across parts of Scotland. 2 Met Office red warnings are issued as Angus records its wettest day since 1891. England and Wales are also drenched, 100 millimetres rain falling widely, making it the third wettest 3-day spell ever recorded and the Midlands wettest on record. The impacts, catastrophic. Floodwaters swallow communities, transport grinds to a halt, power lines fail and lives are tragically lost. And Barbet? It's not an outlier. Each storm season brings more records, more destruction and more data feeding into the story of a changing climate. Britain's winters are getting wetter, but it's not simply a story of more rain. It's about how our seasons are splitting apart, reshaping the very rhythm of our weather. The State of the UK Climate Report, the Met Office's comprehensive annual analysis of observed climate trends across the UK, reveals the scale of this transformation. Drawing on over 250 years of rainfall records, the data paints a clear picture. Across England and Wales, 6 of the 10 wettest winter half years, that's October to March, have occurred this century, 4 of those in just the last decade. Winter rainfall has increased by 16% compared to recent historic averages. The evidence is unmistakable. As we move from spring into summer, we're seeing more frequent spikes in heat, often broken up by showers. According to the latest UK climate projections, UKCP18, short, intense rainfall events like thunderstorms are expected to become even heavier as temperatures continue to rise year after year. This challenges both infrastructure and resilience. How do we prepare for wetter winters and flash flooding summers? In this show, Alex Burkle sits down with Dr. Will Lang, one of our chief meteorologists at the Met Office. Will digs into the latest State of the UK Climate Report, walking us through the science behind these dramatic shifts. Alex and Will explore why the jet stream is driving our wetter winters, how rising temperatures are supercharging summer storms, and where across the UK these changes are most pronounced. From the physics of the atmosphere to the stark reality of what's coming by 2035, they will unpick Britain's rainfall revolution. The government has committed £7.9 billion over 10 years, the largest flood defence programme in our history. Will explains why that investment matters and what we should be really preparing for. Over to Alex.
Thanks very much, Claire. So yes, I'm joined by Dr. Will Lang, one of our chief meteorologists here at the Met Office. Now, Will, we're talking about rainfall. So the State of the UK Climate Report for 2024 came out and it highlighted some strong signals for how rainfall was changing. But where are we seeing the strongest signs of change?
Yeah, well, the key result from the State of the Climate Report was that the UK, and this is observed to be true, is getting wetter. That is predominantly about wetter winters. Or I'll clarify that, wetter winter half of the year.
So the winter half of the year is?
Yeah, let's call that October to March.
Yeah.
And we can see through our observations in recent history and then going back as far as we can that there is a trend towards wetter conditions. Now, some of that may well be down to the sort of usual natural variation. There's a lot of that on timescales of a year or even decades or so. But we do know that there is an underlying increase there, which is due to the trend to increased temperatures. And of course, we all know, and you'll have covered on this, these chats before, warmer air holds more moisture, and that automatically gives you more rain. So that's how we know that there is a climate change component to these wetter winters that we are observing and are continuing to predict that these trends will continue as well.
And so we're expecting wetter winters, which we've already started to see. What other signs are there in the summer?
Well, it's a different pattern in summer, and let's get to why this happens, right? So I'm going to turn the tables on you now, Alex.
Okay.
And
Scary.
remember the times where we were sat upstairs in the forecast room upstairs, and you were my right-hand man.
Yeah.
And I'm going to test your meteorological knowledge. So let's split the year into two. So let's consider that winter half of the year, first of all, October to March. Broadly speaking, we have two types of weather which can dominate in the UK. So maritime weather coming in mainly from the west, continental weather coming from the continent, from the east or the southeast. Now, which is dominant at any particular time can really, really vary, and that's a characteristic of the UK. But broadly speaking, we're more likely to get dominant maritime weather in winter and continental influences in summer. Why is that, right? So what's happening in the Arctic during the winter?
So the Arctic's getting colder, and so then that temperature contrast between the Arctic and near the equator is greater. And so then that's why you get your jet stream, that's why it's quicker and stronger.
And you're answering all of the questions perfectly, yes. So that temperature contrast gets really, really strong, and stronger as we move through that winter half of the year. Because the pole is in the dark, it cools off. We've still got much warmer conditions further south in the equatorial regions and across the North Atlantic as well. So that strengthens that temperature contrast. That means we get a strong jet stream. And as we know, it's the jet stream that develops and steers low pressure systems and other associated fronts west to east across the Atlantic, very often towards the UK as well.
But isn't the Arctic also warming?
It always gets it's about relative temperature. So it's always getting much, much colder during the course of the winter relative to what's happening further south. So both of those are warming overall, but actually the warming that we're getting in the equatorial regions and in the rest of the Atlantic is greater than what we get in the Arctic.
So the contrast between the two is
over time. The contrast is becoming greater. The jet stream is becoming stronger, more active. That's the trend, really, and that's why we think we are seeing this trend towards wetter conditions, primarily in western areas of the UK. So that's again a signal that it's driven by these Atlantic frontal systems coming in over time, right? And moist air, sometimes of tropical origin, holding a lot of moisture because it's warm, hits the mountains in the west of the UK, so southwest England, Wales, Cumbria, western Scotland, etc. That's why we're getting a lot more rainfall historically, and that's showing up also in the climate predictions as well. So that trend is set to continue. We are getting wetter in winter. Now the summer's a different story. It's not dark at the pole anymore. We don't get that strong temperature contrast. What we do get is the heating up, in particular, of the continent. That tends to increase the chance of high pressure extending from the south towards the UK. We can be on the fringes of that. You tend to get drier and warmer conditions dominating in the summer. And that trend is becoming more clear through climate change. Things are getting hotter on the continent. We see heat waves increasing in frequency and intensity. We're on the fringes of that, but we are feeling that increase in temperature, and that is also driving drier conditions in the UK in the summer. So we do get this real, split between what's happening in winter, wetter winters, and what's happening in summer, drier, hotter summers. However, the catch is for precipitation, when it does rain in summer, because of the additional heat we're getting in the system, it is raining with much greater intensity. So this is the kind of rain we get for thunderstorms. So when we do get thunderstorms in the UK, there is evidence that they are becoming more intense. Still probably quite short-lived, still probably quite localised in nature, but the real top-end extremes we get of summer rainfall are increasing, despite it being drier overall.
And so then that means flash flooding, surface water flooding, that becomes more likely because, although we're saying it's drier overall during the summer months, we still get that intense rain and perhaps even more intense.
Exactly. So what we see from historical records, and again from the climate projections, is that the kind of rain in summer which is likely to cause problems in terms of flash flooding, road disruption, things like that, that's becoming more frequent. So 20 millimetres or more of rain in an hour, we know that amount of rain is going to become more frequent. that's not a particularly great amount of rain, as you'll know. I mean, that's probably the bottom end of what is required to cause flooding in urban areas, for example. Yeah. But we see a clear upward trend in that. What is even more worrying is that there seems to be a trend in the real high-end extremes as well. So in history, it is very rare to get a rainfall event, a summer thunderstorm rainfall event, which gives 200 millimetres of rain or more in an hour.
Yeah. Yes.
Right?
Yeah,
Probably tens of times, less than that we know about.
Sure, I can't think of any time that I've talked about.
But of the times we know about, most of them are in recent history.
Right.
And that we think that we can attribute that to this trend, and it fits the science as well. Again, more heat in the system, more ability when it does rain in the summer for that heat to trigger the thunderstorms that give the extreme rainfall with more moisture within them as well. So there is that upward trend. And the worrying thing from a perspective of someone who's interested in warnings and government resilience is how we deal with those kind of situations in the future. Because of these things we haven't really seen yet. I mean, it's a handful of times in recorded history in the UK, but these are becoming more frequent, whether this is 20 millimetres an hour or 200 millimetres an hour. And rainfall amounts anywhere between that range can cause a real problem, particularly in urban areas, London, parts of the Midlands, central belt of Scotland, for example. Nowhere is really immune from getting these intense bursts of rain, and they are becoming more frequent and more intense.
So we've got effectively the two types of heavy rainfall. So we have the more persistent heavy rain that's coming in with the fronts, with the more active jet stream during the winter months, and then the shorter bursts, thundery downpours, intense downpours that can come during the summer months. In terms of the communities and how they're impacted, what's the difference between the impacts and the effects, and how we can become a bit more resilient to them between those two different types?
Well, in a sense, winter rainfall is focused on the areas where it already rains a lot anyway. So those areas need to be prepared for probably more frequent flooding than they see at the moment. They're probably seeing wet conditions and flooding from time to time, but they might see things beyond the experiences they've had before, and things that test what they might consider robust defences from previous years, because they say, well, it's always rained like this. Well, it'll be raining that extra little bit more. So that's going to be a challenge for our communities in those areas. We're also seeing in rain, such as we saw in Storm Claudia the other week, for example, we can see heavy rain in areas which aren't so used to rain, parts of the Midlands, parts of southern England, for example. And those areas also need to be adapted to seeing more rain than they're used to. I think the summer problem is slightly different because anywhere can be affected. We have some evidence of the projected trends in these extreme thunderstorms in the UK. All areas are due to see an increase as we move into the latter part of this century of the frequency of these kind of thunderstorms. What is really interesting, though, is that differences are more pronounced the further north you go. So on average, we're 4 times more likely to see 20 millimetre an hour thunderstorms when we get to 2070. That's in our climate projections. Compared to now. There are big geographical differences, though, in that across the UK. So the changes aren't that pronounced further south. As you head north, though, in towards Scotland, these type events become 10 times more likely. So it's kind of counterintuitive, really, that these areas that you might think are going to be, because they're cooler, but it's that combination of the heat that they do see, plus the moisture that they do get from the Atlantic, for example, seems to make those extreme summer thunderstorms that much more likely in those areas.
So you touched on you said everywhere is going to see an increase, and you mentioned the north seeing perhaps a greater. Are there any other areas where the increase is much less? Or
well, yeah. So in southern areas, southern Britain, there are increases in the frequency of these type of thunderstorms in our climate projections, but it's much less pronounced. What I'm not saying is that it's wetter in these areas, in any of these areas. It's not becoming 4 times wetter. It just means that these particular thunderstorm, intense, short-lived events become more frequent. There is an overall drying trend. And this is, again, the slightly difficult, tricky thing to message, slightly counterintuitive. Drier summers for pretty much the whole of the UK. But when we do get the thunderstorms, they are generally becoming more intense and more frequent.
Yeah, that is a tricky one to get across, isn't it? We talk about dry summers and droughts and hosepipe bans and the issues that we get with that, wildfires and whatnot. But then at the same time, we're also warning of the potential for greater impacts from intense rain.
And this has been one of the difficulties of the last few months, to be honest, as well. So the interactions that we have with government, with our hydrological partners, the Environment Agency in the UK, for example, we're trying to get across that message because we had a really, really dry, hot summer, extremely dry spring, and lots of parts of the UK have been in drought conditions. We remain susceptible to drought at the moment, even though it's been raining a lot, but we're in the situation we are simultaneously concerned about drought conditions, but also flooding as well, because there's been so much weather. They're slightly different concepts. Seems to be mutually exclusive, but they're not. They can happen at the same time.
So I'm imagining that there must be some skepticism amongst some people that you work with. How do you deal with that? How do you make sure we're getting the right message across?
Well, we show them the evidence. So we will show them what's been happening in recorded history, so the actual observations, the actual trends that we're seeing, and there are some clear trends, particularly in temperature increase. You can see upward curves on these graphs, hotter summers, and associated with that we can also see upward trends in these summer thunderstorms, for example. Some of the other things that we talk about are a bit less clear, a bit more indirect at the moment, but usually there is a trend caused by this warming condition. So we start with the facts, we start with the reality, and then we talk about our climate modelling and all of the different scenarios and all of the way that we try to incorporate the uncertainty, the things that we don't know into the system. And generally speaking, these things also show an upward trend as well. So it's about building an argument based on what we're actually seeing now.
I suppose then people can't argue with the facts. And do you find the government, everyone, are they receptive to to what we're saying?
I think it's becoming increasingly difficult to say that climate change isn't happening.
Yeah.
I think it's becoming increasingly difficult as well because of the evidence that we can provide that there isn't a human contribution to that. But that doesn't mean we can rest on our laurels by any means. We need to keep improving the science. We need to keep improving the evidence base to help inform policy. That's what we're there to do. Help the government, help other organisations, businesses make decisions.
So what improvements are we making, both in terms of when it comes to the climate projections, but also forecasting those events, those individual events that are happening? What changes?
So there's a lot we have to do to make sure that we keep up with this. So one of the things that we're always doing is trying to improve our weather forecasting models. And this is where the investment in things like supercomputers and other forecasting systems really pays off. So we can look to model the weather at higher resolution. So that might capture the smaller scale of the thunderstorms or the way that weather interacts with mountains, for example. We can start to run the models more and more times simultaneously. So ensemble forecasting, you'll have talked about before on these chats. So that helps capture the uncertainty of weather. So we can identify the tails of the distribution, the things that are really, really unlikely, but actually we can quantify how unlikely they are. So if we can say there's a 10% chance of getting 100 millimetres of rainfall, people are going to take action on the basis of that. So improving our modelling is one thing. Keeping our forecasting knowledge up to date. So that's the thing that you and I do, Alex, right? So how a lot of that human skill in weather forecasting is around historical knowledge of what's happened before. We are going into territory where we're seeing things that we haven't seen before. So how do we anticipate that? How do we adapt our mental models, our decision-making processes to be able to recognise these unprecedented events that we might see in the future? And then downstream from that, it's how we communicate these things through warnings, how we make sure that our warning systems are future-proofed, can anticipate and successfully communicate when something very extreme is going to be happening. Do we need to have something beyond red, or do we just scale the system upward to cope with those climate
like
change?
a black warning or a red
Well,
plus.
we need to think about these things. I'm not going to say that we're going to do that at the moment. Don't worry about that. But these are the things we need to think about. So, are we triggering the right actions? When we issue an amber warning or a red warning, how do we get across that message that it might be something that you haven't seen before, whether you're a member of the public or a member of the resilience community who has to take preventative action, for example. And then it extends into the wider UK questions about our infrastructure, the way that we respond and plan towards severe weather events, and how we just accept it and understand how to work with it as a society. So which bits do we need to adapt to, which bits we need to mitigate, which bits do we accept that this is something that's going to more frequently happen in the future. So that all of these things are happening at once. I think the Met Office's part is around that, informing the modelling, the forecasting, the evidence base, the underlying science, and helping out with that decision making.
When you talk about adapting, what kind of things can we be doing? How do you think the future is going to look when it comes to dealing with our changing weather?
Well, the first thing is for people to understand what the data is telling us. And that's what the climatological projections is telling us. But also, again, working with partners across the UK, what this is telling us about things like changing flood risk, changing vulnerability of our transport infrastructure, etc. So we can play a part in informing that, probably with and on behalf of partners as well. And then it's about informing policy. Does that mean we need to be changing the way that we do planning, for example, where we put our roads, where we put our infrastructure, where we put our houses? Are we prepared to take these risks in having things exposed to severe weather and extremes? Again, that's not something that the Met Office is there to dictate, but we can help inform those decision makings, I think.
Thanks very much, Will. It's been really interesting talking to you. Thanks for coming on Climate Conversations.
Pleasure.
There's a lot more on UK climate trends on the Met Office website. And for more climate conversations, check out our YouTube channel. Our thanks to Dr. Will Lang for his expertise. From Alex and I, thank you for watching, and we'll see you again soon.